to Camp K12. For those of you who are new, welcome back. For those of you who are coming back for a second or third or 11th time, we love having you here. Today's session will be like the ones before in that we will do about 35 to 40 minutes of conversation with me and our guest, followed by 15 minutes for all of you to ask your questions to our guest. So without further ado, let me start by introducing our guest today. So our guest today is Tanay Kothari. You can see him here. Tanay is joining us from California. I believe it is about 10:30 p.m. for him in the evening, and I'm in California as well, hence this background. And so we're in the same time zone. Tanay is someone that I first met through Camp K12 a long time back. I remember awarding him a prize in one of our competitions at Camp K12. For those of you who may not know the story of Camp K12, it goes back to 2010. I started Camp K12 in 2010. Tani, I believe you and I would have met 2011 or 2012, somewhere maybe
somewhere around then, yeah.
Yeah. And Tane was a young coder back then, used to build a lot of things. We used to organize a lot of competitions for coders across the globe, and he won some of those competitions. So that's where our relationship started. And I reconnected with him much later in the journey. And he's gone on to do some wonderful things since his coding days back in school. So he grew up in Delhi, from what I remember, Tane, and was at DPS Arkipuram in terms of schooling. But then ended up going to Stanford University. How many of you guys know Stanford University in California? And he studied computer science at Stanford. So if you guys know, well, Stanford is well known for many things, but it's well known for being a really great university for studying computer science, for studying anything. It turns out a lot of CEOs and entrepreneurs every year. It's right in the heart of the Silicon Valley in the United States. And as you will see from our conversation today, Tanay has picked up quite the startup bug, which means he likes to use his coding skills to build companies. And we're going to talk to him about why and how that happened. And today he's building his own company in a very advanced and modern field of technology called brain-computer interfaces. I won't spoil it for you, but this is stuff straight out of the movies. And I want you to be able to ask Tanay, what is brain-computer interfaces? And so today we're going to have a conversation about Tanay's life from being a coder in Delhi all the way to being a computer science student at Stanford, to then choosing to build many companies, not just one, all the way up to the most recent stuff he's working on, which is advanced AI technologies and brain-computer interfaces. So with that context, I'll turn it over to you. Tanay, welcome. Everyone, please give him a proper Camp K12 welcome, which is a round of applause.
Thanks for the really kind intro, Anshul. This was
good to have
not
you
as great as you described me to be, but I appreciate it.
No, this is it's our pleasure to have you here. Just so that you get a sense of our audience, Tanay, let's ask all the kids to message on the chat thread what grade they're in. So I want to
really
message what grade you guys are in so that he knows who he's talking to. Go ahead. Wow, second grade, 10th. We've got people from second grade all the way to 11th grade, I think, in this group. Great. Really great. Now I want all the people that know AI and machine learning to message AI on the chat thread. Everyone who knows AI, message AI. Nice. We've got several AI gurus here, Tanay. Some young second to eighth graders that know AI or are taking their AI classes with Camp K12. And I think you guys are going to really identify with Tanay's journey because he started doing AI in school. Lovely to see you guys, so many people from so many different grades having some exposure to AI and machine learning. And don't worry if you don't, we'll talk about what it is and how it's used to make these awesome technologies. So Tanay, let's actually take this journey back to your school days. Maybe give us a sense, before we go to school days, give us a sense of right now, give us a sense of where are you in terms of where in the world are you, and how's your weekend going, for starters?
Sure. Right now I am in San Francisco and my weekend's going great. It's a nice Saturday night. I just had a friend's birthday. So I'm just coming back for dinner for this call and to talk to you guys.
Super. Thank you for doing that. Did you write any code this weekend?
To write any code this weekend? A little here and there, not too much. That was mostly relaxing.
Okay. And do you code during the weekdays?
A lot. Yeah.
So
My work is decently intensive, although now it's becoming less so because our team is growing a lot more and I'm taking more of a managerial role.
awesome. And some of you may not have the context, but then he will talk about it. He's building his own company right now. So when he says work is growing, his team is growing, he's talking about the fact that he's doing his own thing. And when you do your own thing, you can build a team to be able to do more in less time. And so Tanay is building a team in San Francisco to take his company further, which he'll tell you about. One of the things I have noticed about Tanay, guys, is this is a man who started coding at a very young age, and we're going to start by asking him to share his coding journey. But he still codes today. And many of you and your parents ask me, "Hey, so am I done? Am I done with coding? I did a course. Am I done with coding?" And I think what you'll find is people who end up doing great things and building great things. For them, it's more of a journey. It's more of a hobby. It's not like I did a coding course and then I'm done. And so I want you guys to hear a bit about Tanay's journey as a coder and how he started young and then he kept doing it. So let's rewind the clock, Tanay, and go down memory lane and take us back to the days when you were the age group of these kids that you see on the call, and tell us a bit about when did you first start coding?
Sure. I think it's pretty much as old as some of you guys over here. I think this was back in fifth grade. I was 10. And I'd gone to my school's computer lab, and there's a bunch of these 12th graders there sitting and building some Android apps or some games. I didn't know what they were doing, so I like, as any like curious 10-year-old, right? I went up to them and was like, "Oh, hey, what are you guys building?" And they were like, "Oh, you're too young to understand." And no one gets to say that, right? Nobody's too young for anything. So anyway, I go back home, I open up the computer. I think at that time YouTube had just started to become popular, so this is like early days of YouTube. And so I searched on there like how to make a game and how to program, and I did more and more Google searches and started off with building some very simple things like small games or calculators, pinball, that breakout game, if you guys have played, where you have the paddle and you have to hit
That
the
goes
ball
back
around in
to
places.
yeah, yeah, yeah.
So very simple stuff, and moved on from there. And then after that, I got in a couple of my friends, because building with friends is always a lot more fun than building by ourselves. And it's been going on ever since. I was almost 12, 15 years ago now.
No, this is it's a very exciting journey. So tell us more about the programming languages that you picked up back in that day. It was obviously a different time, so I imagine the programming
Yeah.
language is slightly different mix than the ones our kids learn today. But since they are coders, the people on this call,
Yeah.
give us a sense of what languages were you using to build these kinds of games you're talking about?
Yeah. Initially, I started off with Visual Basic. So that's the one they sort of had in school at that time, VB6. And then after that, I started to do some more. So I moved into C Sharp to build apps for Windows Phone and Windows Desktop. And then I learned Java to make Android apps, and then C++ to
Wow.
do some other algorithms level stuff. And then I learned Objective C at that time, and now Swift to build iOS apps. So my sort of like I was going from like one platform to the other as I got a new phone, as I got new friends with other phones that I could build stuff for, and just picking up languages along the way. And I think one of the things that started to become very clear is if you know one language, then learning another one gets very easy. Where at a point, if there's something new that needs to get built, and I look at a language, it'll take a couple of hours to learn a new programming language because it's just the same things that you already know, but just written in a slightly different way.
That's absolutely true. I like to, when I'm talking to these kids about programming languages, I like to compare it a lot to spoken languages we have as human beings for communicating with each other. You can learn Spanish, you can learn French, you can learn German, you can learn other ways of communicating with other human beings. There'll be some sort of a common grammar across
Mhm.
languages, and there'll be, in some cases, overlapping vocabulary across languages, and it's pretty similar when it comes to coding languages. And I think what Tan is pointing out is that as a kid he was exposed to multiple languages, and you guys know that even in your coding curriculum at Camp K12 you guys will do different modules with different languages. The reason we do that is because it makes you, well, one, it makes you confident that you can do anything, whether it's a mobile app like he said, or it's a game, or something else. And the second is it builds the understanding of what's common across all of the languages, so that when you want to or need to learn a new one, you can do it very quickly. So I think Tane is just affirming that that is the case. So Tane, let's go into more detail on what you were building. And so you talked about some games and some mobile apps, and this is all in middle school. You're talking fifth grade.
This is all
Fifth
like
grade.
fifth, sixth, seventh grade.
Okay. So how did the nature of things you were building, the projects themselves, change as you went from middle school to high school?
Mhm.
And when
Sure.
did
So
you
I
start?
can
Yeah,
give
go
a
ahead.
couple of examples, and then from that show, like
Oh, that
the
would be
things.
awesome.
So the first app that I built was a quiz app for this TV show called Big Bang Theory. Um, it's like I don't know if
How many
that's
of you
still.
have seen that show? How many of you have seen Big Bang Theory and know what it is? Okay, few people have.
Oh
I
man,
have.
that's quite a
Yeah, yeah,
lot.
yeah.
So anyway, so the whole plan was, so like you go episode by episode and you answer questions about the show. And me and my best friend Akshay at that time, we were really big fans, and we both were working together. I was the coding guy, he was the design guy, and so we sort of started working on that. And of course, like, okay, if any parents are listening to this call, this is the time when you should close your ears, because I'm going to tell a little secret for the kids, which is, so my parents of course had a limited like computer time, right? Not more than 1.5 hours a day. I'm pretty sure all of you have that too. So what we actually did was, I used to wait for my parents to go to sleep at around 11 p.m. at night, see the light go off, and I used to call my friend up, and it's like, Akshay, they're asleep. And then me and him used to wake up and then code the entire night, and then pretend to be asleep at 5:30 in the morning before my mom came to wake me up. And then the next night we would sleep. So for a few years we just slept alternate nights, so we would get these like long 6 hour stretches at night to just go and build this kind of stuff.
Who
And
is
so
who's
that was,
guilty? Who's guilty of doing the same thing, guys? Who is guilty of coding at night when parents are sleeping? Anyone here? We're not endorsing it, but we just want to see
yeah,
who's
I know
guilty
some
of
people have
doing.
parents
Yeah,
around, so it's okay. You can just secretly type that in.
I'm definitely guilty of the same thing, Tane. You're not alone. I think
Yeah,
it's a very nice, productive time, when it's quiet in the house to just work, and it's an
I know
insanely.
it's fun. It's addictive.
Yeah, yeah.
I just like could not stop.
Anyways,
Yeah,
keep going. You were telling us about how you actually made time to do this, and then how did that kind of the projects change over time from middle
yeah,
school to high school?
for sure. So this one we worked on it for about 6 months, and we eventually published it on the App Store. And I think in the first couple of months we got 10,000 downloads, and everybody's like, "Where's the next version coming up?" And I'm like, "Holy shit!" Like I have my like half yearly exams coming up. Like they have to wait for a couple of months before that goes away, so I can release a new update. And so that's what we worked on then. And then other things like that came up for a few months. And then finally, in about ninth grade, me and another friend of mine, we started working on this project called Convert, which was very simple, right? We wanted to download music, and there was no good way to do that. Like right now, you have Spotify, YouTube Music, like did not exist. You had to download straight up MP3s. And half the time, you downloaded a virus and like spoiled your mom's computer, which is bad enough already. So what we did was we built a system where you can type the name of a song, press enter, and it would search online for that song, find the one with the best quality, and then directly download that for you. So to
Nice.
someone who's using that, who's never used anything like that before, it just seemed like magic. You like type the name of a song, enter, and it's downloaded all in an instant. So it did like within the blink of an eye. We're like, okay, let's make it something more exciting. Because when I was young, Iron Man had just come out. And so I saw that movie and it's like, okay, I want to build something like Jarvis. That was my childhood dream. Like, that is what I want to do. And so what we built then was we added a voice assistant to this music app. And this is the time when Siri did not exist, Google Now did not exist. This was one of the first things with voice that ever came out. And what you could do was you could say, play me songs like Radioactive by Imagine Dragons, and it would find a song like that and play it for you. Or you could say, play me the best pop song right now, and it would find it and I would play it for you. And that made it go extremely viral. Where one morning, like I tried to download songs, it wasn't working. Right. So I called my friend up and he was like, oh, dude, do you know what happened? He's like, oh, let me check. Turns out we had 2.5 million people using our website every single month, and it was running on some free server because I never told my parents about it and I never asked them for any money, and this thing was just crashing like left and right. And so that was sort of the short story on like how things changed over time, because I think what happens is initially you spend some decent amount of time, right, like to build like a simple login page or to make like a feed. But then after you're building it for a while, it just becomes like muscle memory. You know how to make a login page again. You've built it a couple of times. It's easy. And so then you can go one step deeper and build something that's a little more complicated, more complicated. Where at a point, I think around like ninth or 10th grade, building a clone of Instagram or Facebook would only take 3, 4 hours because it's the exact same simple things, just like putting them all together. And so this is like actually like one of the places where someone looking at just like that snapshot, right, would be like, oh my God, like you can build things so fast. It's like unbelievable. But it's just like, no, I've just like done it a bunch in the past before. And it's very obvious, like just copy paste the code and it works again. So I think that was one of the things that made it so exciting. And eventually during like sixth grade to 12th grade, I ended up building and launching 50 different apps.
Wow.
But I mean, that sounds like a really big number, but you think about it. If you just do this every day for a few hours and you do it over 6, 7 years, that's a very long time. You can build anything in 6, 7 years.
Let's ask the audience here how many apps they've built. So guys who are coding with us, I want you to say on the chat thread how many apps or games or websites or AI chatbots have you built. Achintya has built 23 approximately.
Yeah,
Okay.
that is a lot.
uh,
Congratulations.
there's a few
That's
people who built a
200
bunch of
plus.
different. Yeah, yeah.
Yeah.
We've got some experienced young coders here, and
Oh,
absolutely congratulations
100%.
to all of you as well. And Tanay, what I'm noticing from your anecdote here is these weren't just small apps that you built and then put in the corner. It seems like you put them out there for people to use. You put that music search engine you just described, Convert,
Mhm.
you put it out there for people to use, and your mobile apps, you put them out there on the Play Store on for people to download. And it seems like one of the things that I'm noticing about your coder journey is projects for you were for fun, but also you wanted to like you wanted people to use them when you were in school. Like, tell us a bit about the that part of it, because as a fellow coder who started coding at a young age, and as someone who now teaches coding to a lot of young kids, I do believe that one of the differences between uh, dabbling in coding versus going really deep and really learning and putting skin in the game is that piece about letting people use what you create.
Mhm.
And give some advice to these young kids that are currently in school, and many of them said they've coded like 30 projects, 40 projects. I'm guessing that many of those projects are the ones they make in our classes. And how do they take that to the next level the way you did? How do they take that and put it out there for people to use so that they get real feedback from users, so they have a chance to really do what you did and what so many others have done, things that lead to big companies?
Mhm. Definitely. I think one of the main things that was sort of my motivation to launch it for people is just the excitement that okay, there is someone else, bunch of people in the world who are using what I built and they're actually loving it. I actually had this one time when I'd gone to some competition to some other school, and this guy showed up, and he's like, we're talking about music, and he's like, "Oh, dude, you have to check out this app called Convert. It's so good. Like, you can just download music like that." And just for me to see someone else love my app so much to like go around telling people about it. I never told him I made the app. It was just kind of like amusing to just like see him be all excited. And I was just like, I was elated. And I still remember that moment that happened 10 years ago. But to me, it's just like yesterday when I saw that and I felt that excitement. The other thing you get is eventually, so like dabbling is good, right? Like nothing against it. You build 50 apps, you spend days and nights doing it, it gets your coding skills really good. But there's sort of two sides to this. There's this one part which is like, can you build things? And the second part is, can you build the right things? And the
Mm.
right things are things that you would say are useful to people. They make people happy, they make people more efficient, they solve people's problems. The only way you're going to figure that out is by launching that in the public and then seeing if people actually enjoy it. And it happened to me. Like I told you about a couple of the apps that had 10,000, a few million users. There were some that had just 10. And I knew that, okay, I built this thing I thought was really cool, but clearly it's not solving any bigger need that other people have. So it doesn't make sense to put in that much effort into just pushing that. Maybe let's talk to the people who aren't using it and see why. What is it that the app is missing that it's not solving a big need? And so, um, having those conversations with people actually helps you learn a lot more. And you're like, oh my God, I never thought of it this way. I mean, this is the problem that's faced by so many people. And this is sort of the inspiration of all the companies I started in the past. Like Convert was one of them. I hadn't planned on launching that or like working on that, but I started hearing from a lot of people. This service called LimeWire, which is the most common service back in the day, this is like 2012, 2013, right? They were using it to download music and that service shut down. And so everybody's complaining, oh, LimeWire is not there anymore. How do we download songs? And I heard that again and again and again. It was like, well, this is a really big problem. I'm hearing this from literally every single person I'm talking to. Can we solve this? And it's always problems like that that come up and actually end up becoming the most successful app. It's usually not the best design. It's usually not the longest piece of code you've ever written, or if you spend 10 years building it. It's, are you building something that people really want? And this is exactly what happened with Facebook, right? If you see the first version of Facebook, it looked trash. It's just bunch of HTML, little to no CSS, and you know how those websites look, right? Just like completely jank. And so when someone built that up, because well, people wanted to know what classes their friends were taking, and there was no way to find that out. And you come on Facebook and boom, you have all of your friends, you have all of their classes, you can see where they are. And that solved a really big need that people had at that time. And so I just want to preface that. And I think Anshul, this is where you were hinting towards as well, is understanding people is as important as understanding how to code, because then you can bring it all together.
Tanay, I thought that was a phenomenal, I think, just explanation. And also, you touched on something we haven't touched on in the conversation yet today, and we don't always get to touch on in these kinds of conversations, which is not only does coding let you create, but coding is also a tool with which you can change lives and you can
Mm-hmm.
create impact in the world. And we don't talk about that enough because we talk a lot about projects, we talk a lot about games, we talk a lot about these fun things we make. Well, you're touching on the power of coding to change the world, not just learning coding to improve how you think, because it does change how you think, not just learn coding to allow you to be creative and expressive, because it is creative and expressive, but to be able to change the world at a young age. And you said something earlier in this conversation as well, which is that you are never too young to do any
Mm-hmm.
of these. You're never too young to create. You're never too young to try to change the world. And that happens when you take your projects that you're doing and you try to understand what people need and to try to build things that people need. And I think that's what you're pointing out. And I think it's a very powerful statement you made, and also very powerful overall. This idea that coding can change lives, and you talked about Facebook, and there are countless other products that were built during people's school years. And even if they didn't succeed, those same people built that habit of putting their stuff out there for people to use, just like you did. And then by the time they go to college, some of our kids are messaging on the chat thread that yes, Zuckerberg ended up building Facebook at Harvard, and then there were other people. I know you built stuff at Stanford, and we'll talk about that soon. But it builds that habit of not just creative creation, but of trying to solve real world problems and building world changing ideas and world changing companies. So,
Mm-hmm.
absolutely. I would love to transition into talking about some of your more advanced projects, because what I know, Tane, is you do AI software development today, but you didn't start doing it after college. You actually started doing it before college in
Yeah.
school days itself. In fact, when I met you, you were already an AI developer. So talk to us about after you build Convert and after you build these things. Tell us about your AI and machine learning journey in high school.
Sure. So I think when I was in school, so like schoolwork was okay, interesting, cool stuff to learn, but I was always curious about learning new things and new topics. So I used to go on Khan Academy all the time. And then at that time, there were other websites like Coursera and EDX, which had just popped up. So I started looking for courses there and I found this interesting course called Machine Learning. And this is ninth grade, so like 2012, right? This was not a very popular thing. Barely anybody was doing machine learning at that time. So, anyway, I found the course and I started going through it, and it was fascinating. All this time, we had been building these systems that were rule based systems, right? Because essentially, what you do is, well, you have a problem to solve and you write some rules to solve the problem. Let's take a very simple one. Take a picture of it, take a picture, and then you have to detect if it's a girl or a boy. It's like, okay, let's see, like long hair, then like probably a girl. Let's look at like earrings, then probably a girl. If like mustache or a beard, then probably a guy, and so on. You write all these rules, right? But with machine learning, you just give it enough examples and it learns to figure out those patterns all by itself, which is what fascinated me, which means that I could build a lot better systems without that much coding. Because before that, I had built another system um, called Aria, which was exactly like Jarvis. I wanted my own personal voice assistant, so I built one. And essentially, like I could control my computer through it. So I could say, like, okay, open this website, search this thing on Wikipedia, next page, previous page, refresh the browser, play this song, that song. And I had to manually like write down every single command that I could say and what to do. But now I didn't have to, because then I could just teach it some very basic patterns and it could just learn from that. And so I started doing that then. And again, I found a couple of friends who were also interested in it, got them on board, and then we started building stuff from it. So initially, I was looking through tutorials online, getting more familiar with it. But then we started looking around and like, what are the problems that people are having that we can help solve? And so one of the ones that we found were a lot of people, especially if you know about cancer, right? If you detect it at an early stage, there is a very high chance that you can get cured. So like stage 1, and it progresses over time, gets worse and worse. And if you get to stage 4, then there is a very low chance of survival. So we're like, can we help doctors figure this out early on? And one of the ways in which it gets missed out is you take the scan of an X-ray to look for tumors, which is just like, imagine you have this X-ray and you're looking for like small dots in places where there shouldn't be. And to a doctor's eye, like you can very easily miss the small dot, but to an AI system, you can't, because they look at every single pixel very closely. And so we built a system and we work with some hospitals in Delhi to get all of their data and train our models more. And we started working with hospitals. We gave them our software for free, just like try it out and just tell us how it is. The point wasn't to make money, the point was to see, is this a problem that we can really solve? And that taught us a lot. And we entered into a couple of science competitions with it. I actually messaged the people teaching the machine learning course on Coursera. It's like, hey guys, I saw your course, I did a lot of practice, and I built this app. I would love your feedback. I wrote a research paper about it.
Wow.
And they actually replied. I never thought they would reply to a random like 10th grader messaging them who they've never met before from the other part of the world, but they replied, they gave me feedback on my paper. And that actually helped us improve our systems. And we built a custom machine learning model for it that took into consideration the image and some more of the patient information. And our systems improved. And I actually got to learn so much. And I don't think that would have happened if I was just like in my laptop just coding. It was because I was working with friends, reaching out to people, and always asking for help. I think that that's one thing I learned in my life is never be afraid to ask for help from anyone and everyone. Even if like I've messaged CEOs of huge companies like GitHub or uh, many companies that are like many $1 billion worth, and I've actually had some of the founders reply back to me and they're like, yeah, I'm happy to help, let's hop on a call, let's meet for coffee. And it's honestly the most amazing feeling because you never think they'll reply to you, but it's those things that you meet with them, talk to them, and learn from them that actually pushes you forward. And that is sort of, I think, like going forward, what helped me get into Stanford, work on a number of other machine learning projects from then until now.
So in 10th grade, you were building software for doctors to use
Yes.
and to detect cancer from images using computer vision. Is that right? This, guys, is exactly what we were talking about a few minutes ago when we talked about trying to use coding to change the world. And here's a 10th grader who was trying to use his skill to not just build apps and websites for himself and for fun, but to try to apply it um, to medicine and to a really large problem, which is how do you detect cancer from images? And in the process of doing that, I think he's describing a lot of good things that happened and came out of that. Not just the fact that he was able to build a better product, but also in his own life, he got to meet and speak with a lot of professors from Stanford University to get feedback from people in the medical space. And I think that opened a lot of doors for him, perhaps including the college he went to later, and we'll come back to talk about that. But hey, there are two questions that I want to ask you, one from a student and one from my side. So as you were talking, one student asked, his name is Akash, he asked, how did you write so much code in school? Because as you're talking, it's clear that you were like, oh, it's almost like this was your full-time job in school. And I think the reason he's asking this is I think most students are so busy with schoolwork and with assignments and exam preparation. My guess is, Akash, that's why you're asking this. So talk to us a bit about how you created the time. And not everyone here is going to be able to do the every other day of sleeping that you did. Uh,
I do not recommend people to do
exactly,
that.
exactly.
Not help.
So for the majority of the people here, what would be
Yeah.
your recommendation on how to create so much time? That's question number one, and then I have one more for you, which I'll ask after.
Okay. So I think one of the things that really helps, and this is what I've seen with my younger brother too, right? When sort of growing up with him, he's 7 years younger to me, so he's in 11th grade right now. He did not sleep alternate nights, but he is still a phenomenal programmer. And what he does is he sort of made it a ritual, right? Every day he would have some time when he would just build things on his own. And not because he was forced to or someone told him to. He just was excited about it. And what I think about this excitement is initially when you're just starting to program, right? You feel like, oh my God, like I'm getting this right, I'm getting errors, I'm stuck, what do I do? But you do it a little, you do it a little more, and slowly you start getting better. And anything that you're good at, you would obviously be excited about. If you're bad at cricket, you won't want to go down and play cricket every day. If you're good at it, of course, like there's nothing else that's going to be going on in your mind. And so it's the initial amount of practice that it took, and just then being consistent about it. Because if you can take out an hour or two every day, just like a few hours during your weekend, to just sit and build something. And this is hard to do if like someone's forcing you to, because like I don't think things like this can really
Absolutely.
work if someone's forcing you to. You just have to enjoy it. Then I think it
It'll
you
happen.
could build whatever you want.
Yeah. I think that's a really good point. You're saying that, look, you shouldn't even try to spend multiple hours a day coding unless you like it. And if you like it actually becomes very easy because it's no different than playing cricket for multiple hours a day or playing soccer, football,
Mhm.
tennis, anything else for multiple hours a day. It's actually the same then, right? It's almost like you're playing a sport, practicing a hobby. And if you love what you do, you tend to create time for it. And pragmatically speaking, you're saying, hey, weekends are available to you even if weekdays are not. And so thank you for addressing that. I absolutely agree that
Yeah.
loving the act of doing it is as important as loving the idea of creating something, right?
Hmm.
Like you can't just jump to the the finish line. You kind of have to go through the journey. You have to love the journey. And for people who are here, you're probably here because you love the journey, right? You're making time on your weekend to come and hear a conversation from a young coder who ended up doing all of these things. You perhaps like what you do. So I think we can all say that that's something we share in common. And if it is something we share in common, it's something we create time for and are able to because we like it. So thank you
Yeah.
for that. Tani,
Hmm. And
the
I
other
can
question.
just to add on to that, I think like one of the things that do happen is a lot of people have tuitions, right? And that take up a lot of your time. So there was actually almost half a year when I did not was not able to do that much because I was enrolled in Fiji. So on my school days, I would be doing schoolwork, and on the weekends, I used to be Fiji like 7, 8 hours a day, and that was hard. And so after some time of that, I just went to my dad and I was like, "Listen, I want to go to the IITs." Like that was the time that I did not know what Stanford was, right? But this is something that I love to do, and I would hate if I cannot continue building stuff during the weekends. And he knew how much I love to code, right? He's seen me on the computer like 24/7. And it's like, okay, that's fine. And so I think that was one of the decisions I made that I'm very happy about, because this was like in eighth when I was doing Fiji. Um, and like if I had not done it then, I don't think I would be here. I think I
Mhm.
would just be studying for IIT and being somewhat miserable because I was just being very far away from things that I actually found enjoyable. And that would have completely changed everything.
Yeah, I think this is very much connected to finding time to do things that you love, and you
Hmm.
have to love those things for you to actually do those. Um, so thank you for answering that with so much honesty and transparency. I'd love to ask one more question, which is common among the minds of students, even if they're not asking it. But you're young, and you at this point in the story, you're quite young, and you're same age as all of these kids here.
Hmm.
What was your motivation? What was your motivation to do these things? It's something that I've heard kids ask again and again, so I'm asking on their behalf. What was your motivation in middle school to start spending so much time coding? What was your motivation in high school to try to build something to detect cancer using the skills that you had? And was there like a role model you had? Was there a bigger picture you were chasing? What was that, if so?
I think for me, it was at that age, right? At the younger spectrum of it, it was less so about, it was more focused on the fact that I could think of something, I could have an idea for an app or a game, and actually just go build it and have it be seen, have it on my phone, be able to use it, and then put it out there for everybody else to use it. And that's sort of your dream, isn't it? Like if you like painting, like wouldn't it be amazing if you could think of something and just perfectly paint it and then share it to the rest of the world? And it's like, this is exactly what I thought of. And I think that was the thing that always excited me, is being able to bring things out of my imagination into actual reality, and the excitement that I felt when I saw other people use it. That's all I wanted to do. I was like, okay, I have this
Yeah.
idea. I know
It's a
people
very
are gonna.
simple. Yeah, it's a very simple motivation, but I think I know which I identify with it. I think it's that sentiment of seeing the impact of what you are creating in people's lives is a very powerful and addicting feeling, if I may even say so. It's a positive addiction. Once you start doing that, you realize that you can do something in this life and you can do
Mhm.
something in this world. And that alone keeps you going, and it pushes you to make time for things that maybe other school kids aren't. So thank you for that as well, guys. We have just 15 minutes, and I want to be cognizant of the fact that I'm sure kids want to ask a lot of questions. So I'll take just 5 minutes with you, Tanay, and then I'll turn it over. There's a lot we haven't talked about. There's your college journey, and there's also the topic of brain computer interfaces. So what I'm
Mhm.
going to do is I'm going to perhaps move faster through the college piece of it. I think we don't have to talk about how you got into Stanford and the admissions process. I think I'll just ask you to talk a little bit about what it's like to be a student, a college student in the US, well, in the US as well as at Stanford University. So, what is it like to be studying there, and how might that be different from studying in the IIT system in India or other systems? Just talk to us a bit about the culture of being a college kid at Stanford and in the Silicon Valley studying computer science there.
Mhm. Sure. I think one of the biggest things that comes out, which I noticed, which is also why I wanted to come here, is you have a lot of flexibility in picking the classes you want to take, picking the activities you want to do. Like when I came here, they're like, "What major do you want?" I was like, "I don't really know, maybe computer science." Like, okay, we don't care. Like, you just have to pick like a couple of days before you graduate, which I actually ended up doing. I switched my major that I was doing in college like 3 days before my graduation day.
Wow.
And what classes do I want to take? Well, I just went up to department. I was like, I don't really want to take this class. This is not that exciting. I was like, okay, what do you want to take? And that is the level of flexibility that you would just have here, where it's like take whatever classes you want. I took classes in economics, psychology, creative writing. I took classes in physics, quantum physics, chemistry, math, um, applied math, all over the place, like biochemistry, anything that like I was curious about, like, oh, I wonder how like it's like the human body works, or like how the brain works. I never really like looked into that in school before. And just like, okay, let's take a class on it, like human behavioral biology. Let's do that, because there's nobody stopping you, nobody controlling what you can take. So I feel in that way, you have all the optionality to do whatever you want.
You're describing a lot of flexibility in the
You have a
U.S. college.
lot of
I don't
flexibility.
understand. Stanford is known to be among the most flexible out of the top colleges in the U.S. So let's move on, Tane, to the topic that I think a lot of people are here for, which is Jarvis, right? How many of you
Yeah.
guys raise your hand? How many of you guys know Jarvis? Yeah, raise your hand if you know Jarvis, the AI system from Iron Man. Okay. So, guys, we call this talk building Jarvis because Tane, it so happens, is doing something very similar to building Jarvis these days. And Tane, you can tell me if I'm misquoting here or mischaracterizing what you're doing. But he's working on something called brain computer interfaces. And this is stuff, like I said earlier, straight from the movies. So maybe, Tane, if you could just define for us what is brain computer interfaces, and maybe paint the picture in terms of what would a world look like where brain computer interfaces exist, and then we can talk about how one goes about building these things.
Sure. So this is sure like a somewhat involved term, which might seem a little intimidating, but here's how I think about this, right? Your brain works very much like a computer. It takes input, it does some processing, and it gives some output. The question that I ask myself is, can we make it better? Can we improve the inputs? Can we improve the processing? Can we improve the output? Because what drives me is, can I make people 10% smarter and 10% more efficient than they are today? So here's an example. If, for example, let's say you could have faster processing in your brain somehow, anyhow. If that is the thing that you're solving, imagine the things you could do. Imagine if your brain just had like another thing connected to it, so you're never wrong at math. Imagine how much quicker you could do things without need for any calculator, etc. So that is sort of the problem statement that I come into this with. And this is what I define to be brain computer interfaces. That is anything that goes in the realm of making humans a lot more efficient and a lot smarter at doing whatever they are. And sort of take on this that I am working on right now is, well, how do people give output? Well, you can speak, you can write, you can type. All of them are really slow. Like if you've probably noticed, you think a lot faster than you can speak or type or write or anything like that. What if you could talk to a device or anything for that matter with just your thought? You're speaking in your mind extremely fast and it's happening at the same speed. And that is the product that I'm working on right now, which is a device that can understand your inner speech, something just like a headphone you wear. And just like you would talk to your Alexa or your Siri, you could just keep talking to it like this. You're walking down the street, you remember an idea, like, oh, I should take a note of that. Or you're listening to music, you want to change the song, like, oh, play this other song. And without having to take out your phone, without having to look down on a screen or say something, just by thinking you could actually make that happen. And this is something that I believe is going to be out there in the world. Brain computer interfaces are going to be a very real thing in the next 5 years. Everybody's going to have this, right? And you can see some very simple examples of it. You have Fitbits and Apple Watches as devices you wear that measure your heartbeat, measure your stress levels. There's other devices that can tell you how well you're sleeping. And those are ways in which you take input from the body on like, okay, how's the health doing? How's like your like heart rate? Are you resting well? Are you sleeping well? All of those things you're taking as input. And then you expand that out more and more. And there is another company that was created recently called Control Labs. And they had this band you wear on your hand. And if you think about raising your hand, just think about raising your hand, but not actually raise it, it could figure that out. So you could keep your hand on the table, not move it at all, and control a remote control car through it just by thinking of like, I want this car to move forward, the car's going to move forward. And so this is the whole space. And there's a couple of very interesting companies in this space here. There's Neuralink, which all of you have probably heard of. That's Elon Musk's biggest
They've been
company.
about it on the side that, hey, is Tanay working on the same thing Elon Musk is working on? And I think some of them have brought it up.
So I would actually say it's different. And I am more excited about this is because Elon Musk Neuralink requires you to drill a hole in your skull and put wires inside of it, which I don't want to do. I don't know about you guys, but I don't think I'm ready for a surgery yet. But the thing I think of is I don't think everybody's going to get brain surgeries in the next 5 years. But will everybody be ready to wear a band or wear a headphone that's just like on there, no surgery, no blood, no nothing? Of course they are. And my theory on this is there is so much you can get from outside of the body by being connected to it, just by listening to all the signals that are going in through your muscles, through the nerves on the surface of your skin, that you don't need to drill holes inside people for. And that's where we are focusing on when we're doing all of our experiments.
So this is like I said, guys, out of the movies, and it sounds completely crazy that you can write code, the kind of code you learn to make mobile apps and make websites. You can actually write code to build systems that read human thought. That's effectively what Tanay is talking about, right? We can build systems to read human thought and then interface with other technologies to be able to produce outputs and do things but much faster than we can type or speak. And this has many applications, even for people who are unable to speak, right? People who are unable to type, it will help those almost as a prosthetic, but it can also improve human productivity and human efficiency. So I think Tanay here, you kind of see his journey from being a coder in school, right? Building his systems to allow a music search engine, right? That was well before its time and was intelligent and let you search and download things, to then building a computer vision system that detected cancer in images, to now trying to change the world by building a system that can read human thought, and then to control devices and things around it. And you can see that the same coding superpower that he acquired in school has really transformed the scale at which he's working. And that is the power of coding. It doesn't end with a class. You can actually change the world with it. And he's going after one of the most difficult problems that others are going after as well, that you read about in the news. And he's doing it in a different way. He talked about the invasive approach that Elon Musk is using. He talked about his own approach, which is using signals from certain parts of the mind, read from certain parts of the body, and it's a non-invasive approach. So this is completely crazy, and I think what we should do at this point, given the time that's left, is just turn it over to questions. And I would like the first question to come from Angelina, because she asked a very important question on ethics and kind of the flip side of these things. So Angelina, I'm gonna ask you to unmute yourself. And so Tane, we're just gonna allow a few kids to ask their questions about what you've shared. Angelina, go
Yes,
for it.
hello, sir. I can hear you. Yes.
Hey, go for it. Hey, Angelina, we can't see you. Do you have a video camera also?
Yes,
Yeah,
I
we can
can.
see you. Yes, go for
Okay.
it. Please ask your question.
Yes, my question was that since this is going to kind of like allow your thoughts to be done, can it be harmful as well? Because humans are more unpredictable. There are many people who would use it for harm rather than for good. And there could be bad effects as well due to the development of such things.
So that's a very good question, and I'll actually drill down to it because this is one of the biggest misconceptions that happen when I describe this idea. So it doesn't capture your thoughts or every single thing you're thinking. If it did that, then just imagine like you go someplace, someone puts this on you, and then there's no privacy left anymore, right? What it does is if you imagine yourself speaking, right, just in your head imagine yourself speaking, that's a very explicit activity you do. That's something you can control. So it's just like how you think of a lot of things but you don't say all of those. Similarly, you can think of a lot of things but only the things you want to say are going to be captured by this device. So the way I think about this is this has the same level of harm that it can do as a keyboard or a microphone that can listen to you. Is it will take in whatever you want to say and communicate. And I think that that's a very good question because there are some companies, for example, Neuralink actually could get into the thoughts where it would start to become harmful and just completely invading people's privacy. And that's not where we want to go. We just want to make people have a lot more time. Yeah. Does that answer your question, Angelina?
Yes, and I had another doubt along because I had seen another student as well say this question, and it was like since so many innovations are coming up, do you think it kind of makes humans much more like lazier or like less like they don't do much work anymore due to such innovations? And it could like impact on physically and mentally as well for everyone.
So it does, right? And I mean, one of the things that I personally feel sort of like morally opposed to is VR. Because instead of going out and actually meeting people and hanging out with them, you're sitting in your room with this box on top of your head and talking to people who don't actually exist or like are somewhere else in the world, but whatever. It's not actual real human interaction. And these are things that I'm actually afraid of. And some people have that thought, right? Well, it does. But then you have to ask the question that it is still in people's hands. And so even though you might be afraid like, okay, like now cars came, people are not going to walk anymore. You could still make that choice. You could still walk if it's less than a kilometer and then take the car if you have to go really far. But it's hard to always force people to do that. So with the added ease that comes into our life because of all of these things existing, there's always negative side effects, and it is almost impossible to have one without the other. You just have to be conscious of what is it that you're playing with.
Yeah, Tanay, this is the
And
classic question.
will machines
Hey,
like
hey, hey,
can
Angela?
it help
Yeah.
mentally?
Hey,
Uh,
Angela, just in the interest of time, we'd like to give some more students the chance to ask questions. So can I request you to
Sure, sure.
maybe chat on the side and maybe ask your colleagues, and maybe if Tanay has time, he'll respond. I want to give the floor to a few other people, but thank you for your question. And I just wanted to add to what Tanay was saying, this this laziness piece that we're talking about. Any technology that allows a human to be lazy in some areas allows us to improve their productivity in other areas. And the car was a great example, right? People might have said, hey, I used to burn calories earlier and I used to walk and it was good exercise. And now you've given me a car and now I don't do this. But imagine everything else you can do, right? As a society. The classic example from parents is when the calculators were coming out into schools, a lot of parents were objecting, hey, my child isn't getting to do mental math anymore. That's the classic one. And why are you replacing mental math with a calculator? Well, because the important and difficult tasks in life have moved from being mental math to higher order problem solving, right? We're no longer, as humans, that's not our job anymore to just do mental math. There are more interesting problems we can solve when there's a machine that can do the basic 1 plus 1 and 5 plus 5 and 10 times 10 kind of stuff, and lets us build brain computer interfaces instead with our time, right? If instead of building brain computer interfaces, Tanay were stuck trying to do mental math for his machine learning algorithms, then he wouldn't have been able to build what he wants to build. And if he succeeds at building what he wants to build, it can really change the world. So, this technology that brings about laziness on one side also allows for massive improvements in productivity on the other side. So it is a complex topic, but as someone who has been a technologist in my life, and I'm sure Tanay, you might empathize with this, and all of you will use technology for social good and for creation. Uh, there's always this duality, but the way I like to look at it is the impact you can create in productivity and efficiency out for many technologies might outweigh the laziness that it creates in humans, right? That's just one thing I wanted to add. All right, raise your hand if you have a question you want to ask. All right, Syed, over to you to ask a question, and then we'll go to Jal Singhel. Yeah.
Hello, sir.
Hey.
My question is that I am having multiple questions, but related to one topic. Like, what is the role of testing in the development, and how you would your projects, Tamay sir, and how would Elon Musk test his Neuralink project?
That's
Interesting
a very
question.
good question. So I can talk more about, like, first on a somewhat higher level. I think tests are one of the most important, although one of the most boring things you do as a programmer. What it lets you do is, so software is a very iterative process, right? You write something, you add more features, you do this, you do that, and it is very easy to go back and break something and not be aware of it because you might not get in that situation again. So the way I think about testing is in two ways. So one of the ways is called unit testing, where you take a very small piece of it and then make sure that this piece works. For example, you have a login form and you just want to make sure that, okay, if I press this login button, it actually calls whatever function it's supposed to call. At no point should this be randomly disabled or disappear off the screen if like something in the middle is broken. The second is called an end-to-end test, where you're like, okay, I want a user to be able to sign up, log in, and go send a first message. This should always work for all users. So you write a test that does this whole process and you code it up, right? Go to this page, press this button, and so on. And then you make sure that this flow is ready. Now, if sometime later you go and change like how a text box works, for example, this whole thing is going to break. So before you launch it into production and have it broken for all of your customers, and by production, I mean like launching the app and have it live for all of your users, you will be able to find out where this happens. And for us, this is going to be a very core thing. And also for something like Neuralink, like I don't think they're at a point where they have anything to test. They're very early in the process, still trying to figure out the biology of it, because it's a hard unsolved problem. But that is what would be happening, is you would have a lot of tests and half your team at least working on that side of it to make sure things are working as expected and nothing breaks.
Yeah,
Does
in
that
case
answer your
of
question?
Neuralink means while testing it may harm people's life as well, right?
That they do those. So that is actually not part of computer testing. That goes all in clinical trials. So that happens whenever you're making a medical product. You have to go through another process that's regulated by the healthcare industry. And it's called the FDA approval process. You have to do clinical trials with thousands of patients. And it's the same way in which you make any new medicine.
Oh,
Keep testing, see for a while, no harmful side effects. And then finally, when that happens, then you can launch it.
Even building a self-driving car
Yep.
requires a lot of testing. So not just for medical products, but when you're trying to build things that have that kind of risk factor, these self-driving cars drive thousands and thousands of miles without any humans before they start carrying any humans. And even when they start carrying humans, it's a very staged release process. Like right now, there are only very few cities in the United States where these self-driving cars have a license to be able to actually carry human beings. So the government exists for some of these reasons, and regulation exists for some of these reasons. But long story short, yeah, there's a unit testing, there's the actual product testing with from a medical perspective, and all sorts of other things. But very important, and the stakes are much higher when you're building stuff like what Tan is building compared to our apps and games that we build sometimes. Thank you for the question.
thank you.
Jal, do you still have a question? Okay, I'll ask you to unmute yourself, and then we'll go to Sayantan. Yeah.
Yeah, sir, I have a question. I have a question about what is the difference between like Siri or Google Assistant and robots.
So I would think of these as two very different things. So it's interesting you put up that question. I haven't heard that question before, but both of these are essentially, I would think of them as things that do tasks that you tell them to do, right? And whereas Siri or Alexa, the tasks might be anything software related, right? Find me directions, what's the time, change the song. The robot would be doing things in a more hardware space, like bring me the newspaper from the lawn, or like clean the room, or anything like that. So this is a software versus hardware thing. And you can see a world where both of these come together, right? You have a robot which you can talk to just like you see in movies, and we're getting closer and closer to that. But right now, because they're both in their very early stages, we have them working separately.
Yeah, thank you, Tanay. Sayantan, over to you. And then we'll have just one more spot for a question after that. So if you guys want that last spot, message me privately what question you have, and then I will ask one of them. Sayantan, we can't hear you. Nope, can't hear you. You're unmuted, but for some reason your mic may not be working. Don't worry, we'll come back to you. Um, all right, you can. All right, got it. I have a question from Parth. And where is Parth? Let me unmute Parth. Parth, go ahead. I've asked you to unmute yourself. Ask your question. Parth, are you there? Parth Vats. I've asked you to unmute yourself. Weird. You need to unmute yourself from your side also, Parth. Okay, not working. So I guess, Parth, I'm not able to unmute you. So we will skip your question and we will go to. All right. Hey, did you ever do the informatics Olympiad, Tanay? Someone's asking about.
I did, yeah.
Oh, wow. Okay. So let's turn on V Shivansh. He's asking about it. We didn't even talk about it, so he's looked you up, it seems. V Shivansh, I've asked you to unmute yourself.
Hello.
Go ahead. Yeah.
Hi.
Hello, sir.
We can
Yes,
hear
sir.
you.
Yes, sir. How did you perform well in the informatics Olympiad? Means what was your strategy? How you prepared for it?
My strategy was to work harder than anybody else. So at that time, I think for 6 months, I took a leave from school. I only went to school for whatever, like a couple of hours every week for the Monday test, whatever. And the rest of the time, I was just on my computer programming. And there were a bunch of different websites like CodeChef, Code Forces, Spodge, where you would go and practice these competitive programming problems. And I had a couple of really good mentors who used to send me resources, always keep challenging me and motivating me. Because honestly, it was mentally hard to just see yourself not be that good and know that it's your dream to represent the country and just keep pushing yourself every day to keep working. So that was a process. This was in 2015, and I think I started preparing for it too late. I started preparing for it the November before. And eventually, though, I think like at that time I was going 16 to 20 hours every single day. It's like 9 in the morning till 5 at night, just back to back, day after day, drinking enormous amounts of coffee. All of this is really bad for your health. Just people, you should not do this. This is just, it's like desperate times. But that was the core strategy there. And I think just like anything else, this is something for which you need to have a lot of muscle memory, where you can just look at a problem and you know, like, I know this is the answer. Because usually the answers would take you maybe like a day, maybe like a few days to solve if you were just looking at it for the first time. But you've done like hundreds of problems like that before, you can think of it instantly and code it up instantly. And so you would be able to solve those 3 questions in 5 hours, which you're supposed to do over there.
Very interesting. I didn't know that you had participated and done so well. And thanks for asking the question. There is one last question I want to take, which is less about tech and more about doors opening after college from Ryan. Ryan, let me make you the last question. So Ryan, I'm going to ask you to unmute yourself to ask your question about Stanford versus IIT and doors it opens. Go ahead, Ryan.
Hi,
Yeah,
Tanay. I would like to know what doors does computer science in Stanford open for you vis-a-vis computer science in IIT?
That is an interesting question. I believe that, so here's the thing, right? I believe Stanford and IIT both are extremely respected in all parts of the world. Wherever you go, people recognize both of these sets of colleges, the best engineering colleges all over the world.
Right.
The one thing that I feel I have found to be different is the the access you get while you are in college. So when I was in college, right, Stanford especially is very close to the Silicon Valley. So a lot of the founders lived close by. A lot of the founders, so for like companies like the CEO of Slack, the CEO of Zoom, the CEO of Google, like I had like Sergey Brin and Larry Page, I saw them cycling on campus a few times. They were all always so around that you could meet them, you could talk to them, and people of that caliber all the time. That I think had a huge impact on my college experience and just in terms of personal growth. Having found mentors like that within my first few weeks at Stanford, they were sort of always on my side, giving me advice, connecting me to people who could be really of help and help me achieve whatever I was trying to. I think that is the biggest difference in when I like objectively compare Stanford and IIT in terms of what value it offers and what opportunities it opens up. Overall, though, I would say I have seen a lot of people from Stanford go and live sort of an average life, right? Work at a normal tech company, do well for themselves, and just be happy. I have seen a lot of people from, second, third tier colleges from all around the world completely make it to the top. And so I believe there's opportunities that exist everywhere. It's just for you as a person, are you able to reach out, go out of your comfort zone, and just like, are you the person who is always going to be doing assignments and classes, or are you going to be the person who does something other people are not doing? And doing sort of like, it's like from that Robert Frost poem, right? Taking the path less taken. And so are you going to be the person who does that and finds those opportunities? Then you could be wherever in the world and do much better than an average Stanford person, if that's like very objective way of looking at it.
Wow, lovely. So it's about finding your own calling.
I would say like finding your own calling kind of makes it more vague. It's like if you tell that to someone, they're like, I don't know what to do about it. And it's more so just like not being afraid and not always following the herd.
Right.
Yeah. So
Very thoughtful answer, Tanay, and
thank you
for
so
sharing
much.
that.
yeah, and like one example of this I'll give is, and this might be like relevant, is one of my summers I had internship offers from Facebook, Google, and Apple. And I declined all of them. And I went ahead and started my own company. And I was the only person in my year at that time who did that. And to a lot of people, they were like, you're getting paid so much, and now you're unemployed and doing absolutely, it's like you're not getting paid, you're living in an expensive city by yourself, building something. And I ended up selling that company. And that was the best experience of my life. But it was hard. It was hard to say no to all these companies and say no to all these things that everybody else thought was the right thing for them to do. And just be like, nope, I'm gonna do this other thing which feels a little more right to me. And it's things like that that you can do irrelevant of where you are in life.
Right. So from ninth grade, how do I progress towards this?
It's a hard
So
question.
can I actually rephrase the question here, because it's a common one to parents, and in fact is how I like to end this kind of a session with every guest. So Ryan, and I'm guessing your name is not Ryan, but Ryan's mother has asked a question that a lot of parents would be thinking about. So for Tanay, I'll rephrase this as, what advice do you have for parents who whose kids are in high school, beyond what you have already given, on how they can best prepare their kids for life in the 21st century? I'm gonna rephrase that here, and I'll just pause.
So that's a good question, and I get this question very, very often. I have at least one email in my inbox every single week asking about this thing. And the first thing I would start off by saying is, it is never a good idea to pick up someone else's resume or someone else's trajectory and expect your kid to go through the same thing. It's like, I would not do that for my own brother. I would not give my resume to my brother and tell him to follow it, because it's not for him. I think what is most important in these times is to find something that excites you and work on that more. Because if you're looking at all of these US colleges, right, they aren't looking for the smartest programmer. They're looking for the kid who has a spike. And I define a spike as, this person is the best at whatever they love to do. And they're good. They're average the rest. They're like, okay at sports, okay at dance, just whatever. Other things are at a fine level, but there's one thing in their personality that makes them stand out and makes them unique. For some people I met at Stanford, they were just the best juggler, or like the best person at solving the Rubik's Cube. Just anything that they were extremely passionate about, they just put in their all into that. And that is something that I feel makes people the happiest, makes them act to their fullest, and it teaches them a lot about hard work. It teaches them a lot about believing in themselves and knowing that they aren't forced to do something because everybody else is doing it. And so it's like, yeah, I just want to leave it off at that note and make sure that as a parent, I would say the best thing you can do is understand where your children are most skilled at. What is it that is very unique about them that separates them out, and help them develop that skill a lot more. If they are a very creative personality, well, maybe they want to go into product design and like develop apps from another angle, which is more about like thinking about design and user experience and how like it would fit into the journey, and start like interviewing people and need finding. And maybe in a few years after college, they'll be head of product, chief product officer at a company. There's so many journeys out there that I think like coming out here, this becomes a lot more apparent because you see people having had those very different paths in life and like come in with a very like different set of skills that you do need, and there is a need for all of those things out here in the world. uh, so you should always be supportive of them in going through that direction. Hope that answers your question.
Yeah, Tanya, I think that's a phenomenal place to end this conversation. And I just want to acknowledge, we are 20 full minutes over the time for this session,
Yes.
and you have almost 100 people still here listening to every single word that you say. And I'm pretty sure they consider you to be an inspiring role model for them, and that's why they're here. Because I think we're having a very real conversation right now, and we're hearing things that didn't come up in the first part, which reflect kind of the humanity of it all, and just going through life and your philosophy of for how you did your stuff. And I think as someone who has gone through the process, you're perhaps in a better position to give advice than anyone else, as someone who's been successful in it and also has very real principles behind it. So thank you for sharing those principles with us and your story with us. It's very inspiring. And I think there's a lot of good stuff for all the kids and their parents to reflect on there. So I think it's a good place to end. Just want to thank you for sharing your time with us on a late Saturday night. And so everyone in the
Thanks
audience
for the opportunity, Anshu.
no problem. It's our pleasure. Everyone from the Camp K12 audience, please give him a round of applause to thank him for his time.
Thank you so much, everyone. It was my pleasure.
And on behalf of, I would say, the human race, we wish you well on your endeavor with what you're trying to do. I think it'll benefit society. It'll make humans, as you said, even if you can achieve 10% more efficiency for the human brain, that's a game changer. So wishing you the very best. And based on what we've heard today, we think if anyone can do it, you can. So best of luck to you on that.
Yeah.
Take care. Bye, guys.
Take care, everybody.
Great session. Bye-bye.